I just want to show how we handle large fill areas in a return area where we see all the overlapping of the components or end conditions. So you can see here is an area where we have quite a bit of overlap and we're in a large fill area. Now there's a pretty simple way to take care of this. What I'm going to want to do is open up a 2D file. Go ahead and do that now. And I'm going to reference this 3D model to my 2D file. So here's my 2D file. And I know that my 3D model is already referenced. I'm just going to go ahead and turn it on. Here you can see the model reference, and you can see the overlapping in the 2D view. Since all the slopes through this return area are going to be, in my case, 6 to 1, you can kind of see right in this area there's like a triangle. And so they should all meet up essentially in the same location. What you can do is create a template that just has a component or end condition solve out to a horizontal distance. Now if you can see my mouse, that's going to be about right here. So I'm going to turn off that reference file again. And you can see that there's some graphics in here that have already been established for the horizontal constraint that we're going to use to constrain that component or end condition, whatever one you want to use, just to solve into this wedge to avoid that overlap. And I'm going to define that horizontal location from the edge of pavement in my template. So what I'll do is I'll create this line work, and then you can measure it. In this case, we've gone ahead and said what station and what that distance is from the edge of pavement through that wedge area. Now let's go ahead and turn that back on. And you can see we really want it to solve in this area. Let's go ahead and open up that 3D file again. And here you can see we got the model open. Let's take a look at the template itself. Here's the template for the return in that wedge area. So this is, I'm going to make a template drop in that area of just this simple one here. Or if I double click on the point constraint, you can see my end condition isn't infinite. I'm not checking for interception. I'm not placing a point at interception. So really this is just going to be defined by your point constraints. So the default is say, hey look, from the right edge of pavement I'm going to be out 45 feet, but we're going to override that with the values that we got from our 2D file or from what we measured from the edge of pavement, and we're going to fill it in with this value here, the right barn roof horizontal. So if we actually tested that, you can kind of see that, look, I'm going to draw when ground's encountered, I'll keep drawing, but it doesn't really matter where ground is at because we want this template just to solve for that wedge area so we don't get the overlapping in that fill case. If we look at the parametric constraints, this one's already been set up, but you can see that we've just gone ahead and filled that out for the station range for that return to define that horizontal distance where we want this wedge to solve. Now we already have a model set up that has those applied. You can see, once that's applied through that wedge area, that template solves right through here where my mouse is at, and then you won't have any of that overlap. And that's a pretty simple way to take care of any of the overlap in large fill cases.